To understand what standard score means, let's consider this set of statistics. Both the English test and math test, the mean score is 70. The standard deviation for English test is 20, and the standard deviation for math test is just 2. So John's got 60 in English and 65 in math. Although John's math score is higher than English, can we exactly say that he did better in math than English compared to others? Well, the standard deviations would give us a clue. If we look at the English test, because the standard deviation is much higher, that means the data set is more spread out. On the other hand, because the standard deviation for math is so low, that means the data points are so compacted and crowded around the mean. And so when we look at John's, for English, we still see quite a few people with lower score compared to John. But for maths, not really, because most of his classmates are here. So in order to have a fair comparison, we need to have something called standard score, which takes the raw score of John subtracted by the mean of the data set and then divided by the standard deviation of the data set, which is negative 0.5 for English test. And we do the same thing for math test by taking John's math score minus the mean of maths and then divided by the standard deviation of maths. Now, as you can see, the standard score for John's maths score is much lower than his English. That means he performs much worse than English compared to the others. And very importantly, what does that mean? This negative 2.5 of standard score, that means John is 2.5 standard deviation below mean for his maths, which is quite bad. So the answer for this question would be no. So we're going to use this formula for standard score to tackle this question here. So we have a box of batteries and we have picked two batteries. We call it battery A and battery B. And their lifetimes and standard scores are here. And we want to find the mean and standard deviation for the whole set of the box of batteries. So again, this means battery A's lifetime is 0.4 standard deviation longer than average. And battery B's lifetime is 0.6 standard deviation shorter than average. So the standard score is like using standard deviation as a unit to measure how far a datum is away from the mean. If it's positive, then it's higher than the mean, and if it's negative, then it's lower than the mean. So how do we use this information to find the mean and standard deviation backward? So first of all, we let x bar hours be the mean and sigma hours to be the standard deviation of the lifetime distribution of the box of batteries respectively. And it's a convention to use this symbol for mean and this symbol for standard deviation. So for battery A, the standard score is 0.4 and the formula is datum number minus mean over standard deviation. And I arrange that to give equation 1. Then I do the same thing using the standard score of B, which gives me equation 2. Now I have two equations and two unknowns here, right? So I take equation 1 minus equation 2. So this minus this would give me 1 sigma, right? And this would cancel out. So I will get 0.75 equals to sigma. Easy maths. Then we sub this back into either equation right here in equation 1. Then we could easily get x bar. And so the required mean is 12.2 hours and the required standard deviation would be 0.75 hour.